Hello guys, good morning to all of you. Guys, I welcome all of you on my channel, on my YouTube channel, Learn Chemistry with Dr. PLS. Guys, today we are going to discuss briefly on the topic oxidation of alcohols. Oxidation, is it visible? Okay. Oxidation of alcohols. Oxidation of alcohols. So, if I talk about this topic, guys, this topic is very important and questions are asked from this topic, like in every competition exam. Like if you talk about the RPSC first grade, RPSC college lecturer, or RPSC technical education lecturer exam, etc. So, this is very important. And another thing, that Popaff Rule, which is also related to this oxidation of alcohols, is also an important, and many times questions have been asked from this Popaff Rule also. So today we are going to discuss this topic, oxidation of alcohols. So let's start oxidation of alcohols. So first off, we'll talk about the oxidation of primary alcohols. Oxidation of primary alcohols. Oxidation of primary alcohols. Guys, oxidation, like alcohols are of three types. Which are those? Those are primary, secondary and tertiary. See here. Guys, if you feel any kind of problem, or if you have any query, please write me on the comment box. For that query, I will answer, and if that will be a big problem or will be an important problem, then I'll make the video on the topic also. So here, if we'll talk about the alcohols, so alcohols are of three types: primary, secondary and tertiary. See here, alcohols. Alcohols are of three type. See, primary, or I can make here like this, primary. So what are primary alcohols? See here, primary alcohols are those in which OH, hydroxyl group, is attached to the 1 degree carbon. So like this, these type of alcohols are primary alcohols because OH is attached to the 1 degree carbon. Okay, and 1 degree, what is 1 degree? The carbon which is attached to a single carbon is called 1 degree. See, what is secondary alcohol? Secondary alcohols. What are secondary alcohols? Secondary alcohols are those in which carbon attached to the, OH, we can say OH attached to the carbon will be a 2 degree carbon. So see here, this OH is attached to this carbon and this is 2 degree carbon because 2 alkyl group is there, and here 1 alkyl group is there, or we can say only 1 carbon is directly attached to this carbon. That's why this is 1 degree. 2 carbons are attached to this carbon. That's why this is 2 degree or secondary alcohol. And in case of 3 degree alcohols, see here, I can write like this. This is 3 degree alcohols. Why this is 3 degree alcohols? Because the OH group attached to the carbon, that is attached to other 3 carbons. That's why this is 3 degree carbon. So this is basic concept, but if you have problems, you can write me on comment box. I will make a detailed video on this topic. Okay, so come on our topic again, oxidation of primary alcohols. So this you may be knowing that what are alcohols. I'm thinking that you know very well about these. So let's come on the topic. What is oxidation of primary alcohols? So I'm writing here a primary alcohol. This is primary alcohol, and on oxidation of primary alcohols, what we will get, remember, always when oxidation of primary alcohol is done, then we will get aldehyde. I can write here like this. This is aldehyde. We will get aldehyde. And further oxidation of aldehyde, this symbol, this symbol will show the oxidation. Okay. So the oxidation of aldehyde, what we will get? We will get acid. We will get acid. Okay. So primary alcohol on oxidation gives aldehyde, and further oxidation it will convert into the acids. Now, if we'll talk about the oxidation of secondary alcohols, oxidation of secondary alcohol. Okay, so I'm taking the example of secondary alcohol. I'm writing this like this. OH. This will be a secondary alcohol. So, if secondary alcohols are oxidized, then these will convert into ketone. Okay, this is our ketone. And further oxidation can't be possible. Means with a weak oxidizing agent, this oxidation cannot be possible. But if we use a strong oxidizing agent, I'm writing here in short SOA, a strong oxidizing agent. Then what will form? The compound which will form will be like RC double bond OH. And for making product, I think this will be better to make this like CS3. Okay, CS3. So what will be the product? This will be the product. So this is formic acid. Whatever it is, this may be the another chain. So acids will form. So on oxidation of secondary alcohol will give ketone, and ketone on further oxidation will not be possible. But if we will use a strong oxidizing agent, then ketones can be oxidized, and this ketone will convert into acids. So from where this bond will break, from this place or this place, that will be studied. Means what kind of acids will form, this will be studied by the Popaff rule. Popaff's rule, which we will study later. Okay. Now we'll talk about the oxidation of tertiary alcohol. Oxidation of tertiary alcohol. Okay. So see, what are tertiary alcohol? I'm writing tertiary alcohol like this. This is our tertiary alcohol. So if we will oxidize it, the oxidation won't be possible, means product will not form, but if it is react with oxidizing agent, then dehydration will occur. I'm writing here dehydration will occur, and what will be the product? The product will be an alkene. So this kind of alkene we will get. Okay, dehydration means, what is the meaning of dehydration? Dehydration means elimination of H2O. Dehydration means elimination of H2O. So you can say one, like OH is coming from here and hydrogen is coming from here like this, and H2O will remove and this will form alkene. And further oxidation of this alkene, what we will get? We will get a ketone. This will be ketone, and this will also be a ketone plus. Okay. Now this ketone cannot be oxidized, same like this. But if we will use a strong oxidizing agent, it is visible Okay, if we will use strong oxidizing agent SOA, okay, SOA, if we'll use strong oxidizing agent, then same product will form like this. So what will be the product here? Here will be acetic acid plus formic acid. This will be the product. So this is all about oxidation of alcohols. Okay, and what kind of product will form? It is studied. It is studied by Popaff rule. So see again here, oxidation of alcohols. Oxidation of alcohols. In this topic, it is necessary for us to know about what kind of alcohols are there. So alcohols are of three types: primary, secondary, and tertiary. If oxidation of primary alcohols are done, then primary alcohol convert into aldehyde, and further oxidation, it will convert into acids. Okay, now oxidation of secondary alcohol. If secondary alcohols are oxidized, they will convert into ketone. Okay, you might be knowing very well that this is ketone. Now if this ketone is again further oxidized, then oxidation won't be possible. But if we will use strong oxidizing agent, then this ketone will convert into acids, and for making acids, Popaff rule will be followed. Okay, now oxidation of tertiary alcohol. Oxidation of tertiary alcohol. So on oxidation, tertiary alcohols not be oxidized, but it will give dehydration, and a dehydrated product will be an alkene. What is this? This is alkene. This is an alkene. Okay, like this is ketone, this is aldehyde. I think you might be knowing these. So this is alkene. So on oxidation, this alkene will convert into a ketone, and this ketone cannot be oxidized. But again, same like this, if we'll use a strong oxidizing agent, then we will get carboxylic acids. So this was about the oxidation of alcohols. Now we will talk about the Popaff rule. Clear? Okay. So we are going to study about the Popaff rule. Popaff's rule. So guys, what is Popaff rule? You learn here. See, in Popaff rule, the ketones are oxidized. So what kind of product will form? It is told by Popaff rule. So what Popaff rule says? So Popaff rule says that during oxidation of asymmetric ketone with a strong oxidizing agent, I am writing here, during oxidation of asymmetric ketone with strong oxidizing agent. I am writing in short, with a strong oxidizing agent. You know very well that mild oxidizing agent cannot be oxidized ketone. So we have to use strong oxidizing agent always. So during oxidation of asymmetric ketone with a strong oxidizing agent, the carbonyl group goes with the smaller alkyl group, or we can say, or carbonyl group, or we can say carbonyl group goes with the group having more number of alpha hydrogen, So this is the Popaff rule. So what Popaff rule says, during oxidation of asymmetric ketone. What are asymmetric ketone, guys? Asymmetric ketones are these. Like I can write right here, CH3, CH2, CH3, double bond O. This is asymmetric ketone. This is not symmetric. Okay, we can't divide into two equal parts. That's why this is asymmetric ketone. So during oxidation of asymmetric ketone, okay, with a strong oxidizing agent. What kind of agent? A strong oxidizing agent. As we know that weak oxidizing agent cannot be oxidize these ketone, so we have to use a strong oxidizing agent. The carbonyl group goes with the, so guys, problem is this, that from where we have to break, break this bond, like from here or from here, from where we have to break, from where we have to break is like the carbonyl group goes with the smaller alkyl group. So this will go with the smaller alkyl group. This one is smaller and this one is bigger. A smaller alkyl group, or the carbonyl group goes with the group having more number of alpha hydrogen. Alpha hydrogen, this is carbonyl group, this is alpha carbon, and this is also alpha carbon. This carbon is having 2 alpha hydrogens, whereas this one is having 3 alpha hydrogens. So the carbonyl group goes with the carbon having more alpha hydrogens. This is having more alpha hydrogen. That's why the bond will break from here. Okay, so what kind of product will form? We will make the 2 carboxylic acid. One will be CH3, CH2, this is CH3, C double bond O, OH. And what will be this? This will also like CH3, C double bond O, OH. So same product will be here, but it is not everywhere. We will check in our next example. Like now I'm taking the example of this kind of ketone. Okay, guys, if we will use a strong oxidizing agent, then what will happen? The carbonyl group goes with the smaller alkyl group. So which one is smaller? This is propyl and this is methyl, or we can say this is propyl, this is methyl. So this, which one is smaller? This is smaller. So carbonyl group comes with this. Yeah, it means bond will break from here. So what kind of product we will form? We will get CH3, CH2, C double bond O, OH. This is propanoic acid. And second one will be CH3, COOH. So these kind of 2 products will be formed there. So this is the Popaff rule, by which we can find out that the carbonyl group, the which bond can be break, which bond will break, like that. So this is the here product. So Popaff rule, again I'm talking about Popaff rule. During oxidation of asymmetric ketone with a strong oxidizing agent, the carbonyl group goes with the smaller alkyl group, or carbonyl group goes with the group having more number of alpha hydrogens. So I think it will be clear to you. Now I'm taking example of another example of this question. Like now I'm using this one. See, I'm using this one. This is cyclohexanone. This one is cyclohexanone. Now I'm using a strong oxidizing agent. strong oxidizing agent. Again, this is a ketone, and ketone cannot be oxidized by weak oxidizing agent. So for oxidation of ketone, we have to use strong oxidizing agent. And now using strong oxidizing agent, we have to break this carbonyl group either from here or from here, but both are same. So from any place we can break it, here or here, same product will be formed. So product, what will come, what kind of product will be there? See, I'm drawing double bond O, OH, and okay, I'll make it like this. OH, double bond O, OH. Okay, number of carbon should be same, like 6 carbon are here, and here also 1 2 3 4 5 6. So this kind of acid will form, and this is called adipic acid. Adipic acid. Okay, now I'm taking another example. This time I'm taking this kind of cyclohexanone, and I'm using an alkyl group here. So if I'll use a strong oxidizing agent, then this carbonyl will be oxidized, and from where we will break the bond, the smaller size or having more number of alpha hydrogen. So this is bigger size actually, and this is a smaller size, we can say. And if we talk about the number of alpha hydrogen, this is CH, okay, and this is CH2. I can draw this structure like this: C double bond O, CH3, CH2, 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 like this. So you can find here clearly that this is a smaller group and this is a bigger group. Secondly, the carbonyl second, you can write from, you can see here, or the carbonyl group goes with the group having more number of alpha hydrogen. So carbonyl group goes with the group having more number of hydrogen. So more number of hydrogen here. So carbonyl group goes with this group, means bond will break from here. So what kind of product will be there is, I'm drawing here, I can break it from this place, and product will be double bond O, OH, and double bond O, this kind of, if I'll break this, this will be acid, and this will be like ketone. What should I write? Okay, this one, like this. So this will be the product. Okay, so this was all about Popaff rule. And now the second thing is, what are the strong oxidizing agents? So it is necessary for us to learn what are the strong oxidizing agents. Okay, so now again I'm saying Popaff rule. What Popaff rule says? Popaff rule says that during oxidation of asymmetric ketone with a strong oxidizing agent, the carbonyl group goes with the smaller alkyl group, or the carbonyl group goes with the group having more number of alpha hydrogen. Okay, so here both the places are same, but here different. So this kind of product we will form. Okay, now we will see that which are the strong oxidizing agents. See here, I'm writing the strong oxidizing agents. Strong oxidizing agents. And see what are the strong oxidizing agents, and you have to remember always. One is concentrated HNO3. Concentrated HNO3. This is a strong oxidizing agent. Okay, second one is CrO3. Third one is K2Cr2O7, potassium dichromate. Okay, and fifth is KMNO4. Sorry, fourth is, what I'm saying is, fourth is KMNO4, potassium permanganate. So these are the strong oxidizing agents. Okay, mainly these are used. So what are strong oxidizing agents? Concentrated HNO3, CrO3, K2Cr2O7, potassium dichromate, and KMNO4, potassium permanganate. So this was all about this class. Hope you may be benefited from this class, and watch this video again and learn these things. Okay, if you like this video, please click on like button, share with your friends, and subscribe the channel. Okay, bye. Thank you.